Are we alone in the universe? If there are indeed other civilizations out there, why haven't they contacted us? Why haven't we heard from our cosmic neighbors? It's hard to believe that we're the only sentient beings in this grand cosmic theater. Our universe is vast. There are billions of stars in our galaxy alone, and the universe contains billions of galaxies. With the sheer number of celestial bodies out there, it's almost a statistical certainty that life, in some shape or form, exists beyond our blue planet. Which brings us to the perplexing Fermi paradox. If the universe is teeming with life, as our calculations suggest, why is it so quiet? Where is everyone? The Fermi paradox, named after the physicist Enrico Fermi, presents a contradiction that has puzzled scientists and philosophers for decades. The Fermi paradox refers to the apparent contradiction between the high likelihood of the existence of extraterrestrial civilizations and the lack of evidence or contact to substantiate this belief. Enrico Fermi, the man behind the paradox, was an Italian physicist known for his work on the development of the first nuclear reactor. The paradox itself, however, was born out of a casual lunchtime conversation. Fermi, while discussing the possibility of advanced civilizations in our galaxy, suddenly blurted out, "Where is everybody?" This simple yet profound question encapsulates the essence of the paradox. Here's the crux of the matter. Given the sheer scale of the universe, with its billions of stars and potentially habitable planets, it seems highly probable that intelligent life must exist somewhere out there. Yet despite decades of searching, we've found no signs, no signals, no intergalactic postcards, nothing. This glaring contradiction between the high estimates of probability and the lack of evidence is what forms the Fermi paradox. Perhaps we're simply not listening in the right way. The Drake equation is a crucial piece of the Fermi paradox puzzle. This mathematical formula, proposed by astrophysicist Frank Drake in 1961, is our best attempt yet at estimating the number of advanced civilizations in our galaxy, the Milky Way. The equation itself is a series of variables multiplied together. Each variable represents a key factor in the development of advanced civilizations. For example, the first variable is the rate of star formation in our galaxy. Next up, we have the fraction of those stars that have planetary systems. Then the average number of planets that could potentially support life per star with planets. Next, we consider the fraction of planets capable of supporting life where life actually emerges. It's not enough for life to start. It needs to evolve, learn, survive, and become intelligent, followed by a fraction of that life that develops into intelligent beings. The penultimate variable is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. If a civilization never learns to broadcast its existence, we'd never know they were there. Finally, we have the length of time during which such civilizations release detectable signals into space. This is a sobering variable. Civilizations might not last long, either self-destructing or falling victim to cosmic cataclysms. Each variable in the Drake equation is a gate, a hurdle that life must clear on its journey to becoming a civilization we could potentially communicate with. When we plug in our best estimates, the result is a surprisingly large number of potential civilizations. 100,000 civilizations in our galaxy alone. 100,000 civilizations mean they should be everywhere, right? Transmitting signals in every direction, yet we've heard nothing. No signals, no hello, no evidence of anyone out there. Considering the Drake equation, the silence from the cosmos is indeed a puzzling paradox. Scientists have proposed several solutions. Now let's explore some of the most popular theories that aim to unravel this cosmic conundrum. First off, we have the zoo hypothesis. Now, this isn't as wild as it sounds. It's the idea that we're like animals in a zoo and advanced extraterrestrial life is watching us. But they've decided not to interfere. Think of it like an unspoken prime directive from Star Trek, where advanced civilizations agree not to mess with the natural development of less advanced ones. It's a plausible theory, but it does make you feel a bit like gazelles in National Geographic, doesn't it? Next up is the rare Earth hypothesis. This theory suggests that the conditions required for intelligent life are so incredibly specific and complex that they might be extremely rare, even in the vast cosmos. It's not just about having a planet in the Goldilocks zone where liquid water can exist. You also need a whole bunch of other factors to line up perfectly, from the right kind of star to a stable planetary orbit, to the presence of certain chemical elements. Maybe we're not alone, but the neighbors are just very, very far away. Lastly, there's the possibility that civilizations are actively avoiding contact. This is often referred to as the dark forest solution, named after a concept from a science fiction novel. The idea is that civilizations might be keeping quiet to avoid attracting the attention of more advanced, potentially hostile civilizations. It's a bit like being in a dark forest where it's safer to stay quiet than to shout out and reveal your location. In an even darker scenario, a highly advanced super predator civilization could systematically silence all other civilizations to eliminate any potential competition, wiping them out one by one. Perhaps we should have reconsidered before sending that greeting with directions to Earth back in the 60s. These solutions, though fascinating, are yet to provide a definitive answer to the Fermi paradox. But they do give us a lot to ponder on. The Great Filter is a theoretical idea that suggests there is a barrier or obstacle in the development of life that makes the existence of detectable extraterrestrial life rare. The Great Filter can be interpreted in different ways. It could be an internal event or process that poses a challenge to the development of intelligent life, such as the emergence of life itself, or the evolution of complex organisms. Perhaps civilizations tend to self-destruct before reaching a level of technological advancement that allows for interstellar communication. Or maybe it's a natural disaster on a cosmic scale. Here's where it gets even more intriguing. The existence of the Great Filter raises a crucial question. Have we as humans already navigated this cosmic challenge, or does it still loom in our future? If it resides in our past, we can breathe a sigh of relief, knowing that we've already weathered the worst and come out the other side. We've dodged the cosmic bullet. However, if it has yet to come, that's a different story. It signifies that the worst is still ahead, suggesting that our journey toward becoming a Type 3 civilization could be cut short. This possibility implies that, like many other life forms before us, we might encounter this barrier and never surpass it. So, we're confronted with a chilling question. Have we overcome the Great Filter, or does our extinction still loom in our future? Are we alone, a unique spark in the vast cosmic dark? Or are we simply an ordinary phenomenon yet to connect with others in the galactic neighborhood? Perhaps it's not a matter of their absence, but rather our inability to comprehend their mode of communication. What if we have already received direct messages from extraterrestrial beings? Before you dismiss this idea as pure science fiction, what if I told you that we've received a very strange, mysterious, unexplainable signal originating from the constellation Sagittarius? Is it possible we are on the brink of our first encounter with beings from beyond the stars? Watch the next video to learn more about the remarkable WOW signal